Hello, my name is Mr. Asprey and this is my Edexcel IGCSE exam series 2 and this is number 46, similar shapes 2, where we're looking at volume and area scale factor. Now if you don't know, I've split up the whole IGCSE into 60 topics and I've made worksheets of exam questions on each of those topics. I've done it twice. Series 1 I did a couple of years ago and now I'm doing series 2, a bit longer, and hopefully the quality of the video is slightly better as well, but we'll see. Okay, so we are now looking at two shapes, both of them pentagons, both of them regular, which means they're both similar to one another, and it says that EJ is 4 lots of EA. So if we call this X, then EJ is 4 times that, which makes that 4X, which means the whole side of the larger pentagon we could call 5x. The area of the small one is 8 centimeters squared. Calculate the area of the shaded region. So in the first instance we know the scale factor of the big one to the small one. Well, the big one has a side length of 5x and the smaller one has a side length of 1x. Which means that the scale factor is 5. So the linear scale factor is 5. Now if we want to find the area scale factor, we have to square the linear scale factor. So it's 25 times larger. Okay, so the pentagon, which is they call it AFGHJ, the larger one is equal to the smaller one times by the area scale factor, so 200. And this means that the shaded region is 200 minus the unshaded region of 8. So it's 192 is our final answer. Okay, next is a classic question whereby we have two objects and we're told the area of one and we're told the area of the other. So that means that if we want to work out a scale factor between them, it will be the area scale factor, which is k squared. So we take the larger one and then divide it by the smaller one. That's what I tend to do. And that will therefore give us 864 divided by 384. So that's 9 over 4. Perfect. So if I want to find the length scale factor next, then I have to square root the area scale factor, which gives me 3 over 2. And then if I want to find the volume scale factor, I have to cube the length scale factor, which gives me 27 over 8. Okay, so if I just do a quick diagram, this one's A, it's the smaller one, so this is B, the larger one. Now, if I want to go from volume B to A, I need to get smaller, so I need to divide by the volume scale factor. So I take my 2457 and I divide it by the volume scale factor, which is k cubed, and that's going to give me the volume of the smaller shape. So I'm dividing that by 27 over 8. And we get a nice number of 728. Perfect. Okay, next one. I really hate this question. The circumference of the circle B is 90% of the circumference of A, which means B is the smaller one, and it means that A is the bigger one. And it means that if I want to go from A to B, I would need to multiply by 0.9. So therefore, we could call that the scale factor. It does take from the larger to the smaller. It's still a scale factor, and that's fine. Now we're looking at the area scale factor. Well, we know that they're linked by squaring. For area, so squaring 0.9 gives us 0.81. Okay, and then it says find the ratio of A to B. Right, so if I call the larger one, if I just call that 1, we could call it just like 1x, for example, or just 1, then the smaller one will have to times the area by 0.81, so it'll be 1 times 0.81, so it'll be 0.81. Okay, so that's the ratio between them. Now we want circle A first, so if A is 1, then B area is 0.81. It doesn't say that I need to simplify it or write it in any other form, so I'm just going to write it like that, 1 to 0.81. Perfect. But having said that, that does look quite messy, so let's times both sides by 100 to get 100 to 81. That's nicer. Lovely. Okay, next we've got square E has side length E and F has side length F. The area of E is 44% greater than the area of F. Okay, so E is the larger one, and these are squares. E is the larger one, which means that F is the smaller one. And if I was to go from here to here, the area scale factor would be 1.44 because I want to multiply by something in order to make it 44% greater, so that number would be 1.44. Okay, so therefore the linear scale factor is the square root of that, and the square root of 1.44 is equal to 1.2. So once again, if I call F 1, if it just has a value of 1, then E will have a value of times through by 1.2, you'll have a value of 1.2. So the ratio of the lengths, E to F, will be 1.2 for E, dot dot 1 for F. We can times these both by 5 if we wanted to get 6 to 5 to have it in whole numbers. Okay, next question. We've got two similar shapes. It looks like chess pieces, queens. The surface area to the surface area of A to B is 3 to 4. Okay, and the volume of shape B is 10. So when you've got it in ratio form, it's just easier just to keep it in ratio form, I find. So these are the k-squared ratio because we're looking at area. So if I were to square root both of these, that would give me the k ratio, which would be the square root of 3 to the square root of 4, which is 2. And then if I wanted to find k cubed, then I would have to cube these ratios. So I can do that by going to my calculator and just pressing the square root of 3. I would want to cube that. And hopefully, if you've watched my third video, you'll know that that is 3 root 3. And then if we take 2 and we cube that, we get 8. Okay, so this is the scale factor ratio for the volume. Now, this is A and this is B. And we're told that the volume of B is 10. Okay, so what I can do here is I can just use some ratio skills here. How can I get this to be 10? What do I have to multiply by? Well, I can, first off, before I get to 10, I can divide both sides by 4. And that will give me to 2. So that will give me 2 on this side, and it will give me whatever this is. It will be 3 root 3 over 4. It's fine. We'll work out the decimal value once we've finished. And then I can continue by multiplying this by 5, and this will get me to 10 on the right side, which is what I want. And then if I multiply this by 5, this will give me 15 root 3 over 4, and that will be our answer. We want it to 3 significant figures, so we have to do 15 root 3 over 4, and we'll get an answer of 6.50. Gosh. Okay, this one's slightly more straightforward because we've got the height of A and we've got the height of B. So we can work out the scale factor, the linear scale factor, because we're talking about one dimension, we're talking about height, is the larger one divided by the smaller one, so 1.5, perfect. And we're now looking at volume in the next part of this question, so let's go straight and work out the volume scale factor by cubing the linear scale factor, which gives us 3.375, I think. Perfect. Okay, now let's read the actual question. It says the difference between the volumes is equal to this. Okay, so we need to use a bit of algebra here. So let's call the smaller one x. The volume is equal to x, which means to get to the larger one, we've got to multiply by that scale factor for volume. So we'll get 3.375x will be in the larger one. Now the difference will be the larger volume minus the smaller volume. That'll be the difference, and we're told that's equal to 1,197. So if I have 3.375x and I take away 1x, I get 2.375x. And then if I divide through, this should give me my value of x, which is actually exactly what I'm looking for, because x represents the small vase's volume, and that is the question that they've asked. So I need to do 1197 divided by 2.375, and I get a nice round whole number, which gives me confidence is correct. So it doesn't ask me to round my answer to 3 significant figures, so I should be looking at a nice whole number. Okay, next question. Again, this one looks like quite a straightforward one, because we just told the volume of A and the volume of B, so that means we can work out the volume scale factor, which is k cubed, which is, I'm going to do the larger one divided by the smaller one, which I'd always recommend if you can, and this will give us k cubed. So 4372 divided by 1836, we get some lovely cube numbers there, so that fills me with confidence. So to find k, we just need to do the cube root then of the volume scale factor, which gives me 4 over 3. Yes, it does. Okay, now the question is asking for the surface area, which means we're going to need k squared in order to convert between areas. As area is the second dimension, we're looking for k squared. So just square that, and we get 16 over 9. Now, which way do I need to go? So I want to work out A. I've got B, and I want to go back to A. So we're going to be dividing by the scale, by the scale factor. So we're dividing by 16 over 9. Perfect. So it is 1120 over 16 over 9. And that gives us 630. Again, a nice neat number, which doesn't need to be rounded, which is great given that they're not asking us to round. Okay, another ratio question. I always find these ones much harder than just the standard. Okay, so these are tricky, but we can do this. So surface area is this ratio, and the volume is that ratio. Work out the ratio of the height. Oh, wowzer. Oh, sorry, fine. AB and BC. Okay, right. Okay. Relax, don't panic. Let's look at the yellow one first, and what we're going to do is we're going to square root it, because this is k squared. So if I want to find k of A to B, which is the linear scale factor, I have to square root the surface area scale factor. And when I square root 4, I get 2. And when I square root 9, I get 3. Perfect. And now looking at the blue one, I also want to find the linear scale factor. But this time it's between B and C. So because I said the blue one, so the green one is volume. So I'm going to take the cube root of each of these. So I'll do the cube root of 125, which is 5. And then the cube root of 343, which is 7. Perfect. Okay, so now we have two ratios for the linear ratio, which is the same as the height, because the height is one-dimensional. We want A to C, so we need to connect these up. We need to essentially eliminate B. So if I times this one through by 5 and this one through by 3, that will match up the B's. So this one gives me 10 to 15, and this one gives me 15 to 21. So now I can write it as A, B to C, because we have 15 for B in the middle for both. So therefore, if I'm looking at just A and C, I can just get rid of B, and it's going to be 10 to 21. Right, lovely. Love that question, actually. That was quite good. Okay, next question. We've got these wooden blocks, which are mathematically similar. There are small blocks, there are large blocks. The volume of each small block is 300. Given that the surface area of each small block to the surface area of each large block is given as this, work out the volume of the large block. Perfect. So the yellow bit is the surface area, which is k squared. And we're told that that is from small to large, that's equal to 25 to 36, which are nice square numbers, which is great, because when I want to find the linear scale factor, I just have to square root. So I get 5 to 6 by square rooting 25 and square rooting 36. So now I need to find the volume scale factor, and I'll do that by cubing the linear scale factor. So 5 cubed is 125, and 6 cubed is 216. Okay, so now I want to use this ratio to find the value of a small block, which is 330. So I'll just use like the unitary method, which is essentially I'm going to divide both sides by 5. And what will that give me? That will give me that will give me 25 over here, which is a multiple, which is a factor of 300, so that's going to be helpful. And on the other side, 216 divided by 5 is going to give me 43.2. Okay, so now I can multiply through by 12. This might not be the most efficient way of doing it, but it's just how my brain works, because that is how I'm going to get the left-hand side, which is the small blocks, to be exactly 300. So 25 times 12 is 300. And then the larger blocks will be, times that by 12, will be 518.4. Perfect. So the volume of the larger block is 518.4 centimeters cubed. Lovely. Okay, final question. The volume of the statue B is 20% less than the volume of the statue A. Right, so let's set up a scale factor here. We're talking about volumes, that's k cubed, And if I'm going from the volume of B is 20% less than the volume of A, so therefore it's 0.8. So if I take A times it by 0.8, that's 20% less, and that will be how much the volume of B is. It says the surface area of statue B is K% less than the surface area of statue A. Work out the value of K. Okay, so a bit annoying that this is actually K and I'm using K. But let's just rock it. We could deal with that. Let's call this one capital K. Okay. Okay, so capital K will be the cube root of 0.8. So I will just take the cube root of 0.8 and I get, not a nice number, 0.9283. But that's fine because it does say that I need to round my final answer, so I'm not too worried about this. And then if we want to convert between area, we're going to have to find capital K squared, which we'll get by squaring K, which is still in my calculator, which gives me this. Okay, so that is what we need to multiply to convert between areas. So a 0.8617 multiplier is the same as 86.7% of. So what is the reduction? How much less is that? So we have to take 100% and subtract this to work out what the percentage change is. So it's 100 minus 86.17, which gives us 13.8% to three significant figures. Perfect. Okay, right, I hope you enjoyed that. And I will see you in the next one. Bye for now.